Hi, I'm Parveen Patel and I have completed the phase 1 of 14 days Databricks AI Challenge 2 Advanced, and for its phase 2 I have built an end-to-end AI powered supply chain risk intelligence system using the Databricks, and the whole challenge is organized by Indian Data Club, Databricks and Code Basics. And building on my export operations background, I chose the supply chain and operations domain. And this project is about predictive analytics and machine learning. This is designed to help the businesses predict and manage supply chain disruptions more effectively. So in most supply chain systems, team reacts after the delays happen. But in real world operations, what businesses actually need is visibility and early warning. Something that tells them which shipments are likely to get delayed before it happens. So instead of just building a model, I focused on building a complete system that can monitor, predict, and support decision making. And the objective of this project is to predict whether the shipment will be delayed or not, and making it a binary classification problem. So to build this system, I worked with multiple sources, and because the in real world production scenarios, data doesn't come from a single clean source. So the primary data set in this project is e-commerce shipping data set, consisting of 10,999 records, 12 variables, and it includes the shipment level information like how the shipment was transported, ship, flight, or move, road, which warehouse block handled it, customer interactions like number of calls, ratings, then product related factors like cost, importance, and weight, and most importantly, whether the shipment was delivered on time or delayed. So, this forms the core operational data set. Now, in real supply chains, delays are not just caused by internal factors, external conditions like weather also play a role. So, I used a historical weather data set which includes hourly weather observations such as temperature, humidity, and pressure across the multiple cities. And since there was no direct mapping between the shipment locations and weather data, I simulated a weather impact feature using the severity index, and this allowed me to still incorporate external risk into the system while keeping the pipeline realistic and structured. And in real world system, this can be replaced with the location based API integration. And one more important thing I want to highlight is that the both the data sets were originally available in multiple CSV files, and I had downloaded them from the kaggle.com, and especially the weather data set where each attribute like temperature, humidity, pressure, they were stored separately. So the first challenge was not modeling, it was data engineering. Now I will walk you through how I structured the entire system into the database. And here through the catalog, I created a catalog which is supply chain AI. Then I created three different schemas like bronze, silver, and gold under this catalog. Then I did the data ingestion in then which is like uploading the 8 CSV files of both these data set together in the Unity catalog volume, for which I created a volume that is raw underscore data under the catalog supply chain AI schema bronze. Then I copied the paths of those all 8 CSV files so that I can load them into my bronze layer. So my first notebook is bronze data ingestion, where you can see those loaded raw CSV files into the system, that are train CSV is from the shipping data set, and other 7 CSV files are from the weather data set. And I used the proper catalog and schema, and then I did the volume based data ingestion, which is reading the data correctly and writing as a delta table. And most important step in this layer is I use the column cleaning function, df clean underscore columns here. This is important because it avoided many multiple issues in the downstream layers. And I also created the multiple raw tables, like for temperature there is a temperature raw, for humidity there is a humidity raw, and for pressure there is a pressure raw, and so on. So in the bronze layer, what I did is I ingested raw shipping and weather data sets from Unity catalog volumes and stored them as a delta tables without the transformation. And this is important because it ensures the data traceability and reliability and the ability to go back to the original source at any point. And in the bronze layer, it is important because here the data integrity matters most. And I've also added the markdown. You can see there are many markdowns in the notebooks. So these are very important because if someone else want to reproduce my analysis, then there should not be any confusion. So now let's move to the second notebook, that is silver weather transformation. This is my silver layer where the focus is on cleaning and structuring the data, and I here selected the relevant columns. Then I standardized the formats. I ensured the consistency across the data sets. And most important step in this layer is this unpivot logic, that is stack expr as city value name. This is important because weather data was originally a wide format and I converted it into the long format. That made my data usable for joins. And I also used the reusable function design, that is def unpivot underscore weather df value name, because it avoided the repetition. And then I created the single unified weather dataset but by combining the all weather features that has correct joins on date time and city. And in data cleaning step, I removed the incomplete records, ensuring model ready data. And you can see that this row count for the delta table supply chain AI with silver weather clean is showing that all joins have worked properly with no accidental data loss. So here in the silver layer, all I wrote this to delta table weather clean, which is ready for gold or ML. So let's now move to the gold layer, which is my third notebook, that's weather feature engineering. Here the data becomes ready for machine learning, and this is a very strong ML ready feature layer because here I did the time based feature engineering. You can see here that this helps in this helps the model detecting the patterns like peak hours, weekday or weekday versus weekend, and seasonal effects. And I also created the business logic features like extreme temperature flag. Then there is a pressure drop flag, wind risk index, and together these are called weather severity index, which will be used for delay prediction. So output table in gold is supply chain AI dot gold dot weather features. And I also did the optimization, delta optimization using the optimized Z order by query. And I also did the time travel, that is version as of 0, you can see here. So you can also see the other markdowns as well here in this feather feature engineering notebook. So this is very important to understand this gold layer. But my final gold notebook is in the fourth notebook, that is supply chain weather risk model. So here I have done the machine learning and predictions. So again data is loaded for shipping raw and simulated weather features. Then I most important step here, I use this code, that is rand multiplied by 3 dot cast integer. This is important because it is generating the random weather severity index, and it is an intentional workaround logic because shipping data set has no city date time mapping. So real join was not possible. That's why I simulated the weather impact using a randomized severity index to demonstrate how external factors can influence delay predictions. And in real world system, this would be replaced with actual joins. Then I did the string indexer code encoding required for ML. Then I used the customer behavior, product features and logistic features and weather severity index as a feature selection. I used then vector assembler. Then I did the 80-20 trend test split and selected the random forest classifier model because it is robust, it handles the non-linearity, and it is very important because it works well with on mixed features. So I got a very good, I can say I got a good model performance with around AUC score of 0.74, and I used MLflow that shows life cycle management, and I got crucial features for business explanation like discount offered and waiting grams. So the final goal output which will be used in the dashboard is shipping delay predictions, and this is about the gold notebook. But gold layer here, whatever predictions are there, they are stored in the layer gold layer as a delta table. So this enables the downstream analytics, dashboards and operational decision making based on a predicted delivery risk. And I have also given the markdown for model performance summary. So um, here is the final gold notebook, but there is one more last notebook that is about the pipeline or integration, which is real-time supply chain risk pipeline. And here I am reading the final predictions table. Then I did the shipment versus weather risk analysis, which identifies the shipment, which shipment modes are most affected by weather severity. And I also derived the product category disruption risk, which evaluates which product importance categories experience the highest delay probability. Then I also did the warehouse delay risk analysis, which identifies warehouses where shipment delays are most likely. And the most important part of this pipeline is AI disruption alert engine because it flags the high risk shipments which are having the predicted delay probability above 70%, and this acts as an early warning system for supply chain disruptions. So you can see here that final gold table, that is supply chain AI gold supply chain risk dashboard, which is ready for the SQL dashboard which I have created. I'll show you. And so this, I want to say that this pipeline generates the delay predictions and aggregates the those predictions into the business ready insights, and this helps the business stakeholders to identify the high risk shipments like across the warehouses, shipment modes, product categories and weather conditions, so they can optimize their supply chain decisions. And now I will show you the SQL dashboard which I have built that acts as a supply chain risk control tower, for which I have ran 5 different SQL queries. You can see here like overall delay risk KPI, shipment mode risk, warehouse delay risk, weather impact chart, high risk shipment table. So all these queries giving those 5 visuals in my dashboard, which is supply chain risk control tower. And this is important why I gave this name because it is a centralized AI enabled dashboard that provides the real-time visibility into the risks across the entire supply chain, and it helps the organizations predict the, monitor the and respond to the supply chains very quickly. So let's go to the visualizations. The first one is overall delay risk KPI, that is giving the overall supply chain delay risk in percentage, and this shows that around 34.91% of shipments are at risk of delay. So this gives an immediate understanding of how the significant the problem is. For a business, then this number helps answer how big is the risk overall. And let's see the second visual, that high risk shipments table. Here you can see that it is based on a model predictions. So this is one of the most practical outputs of the system. You can see that instead of just showing the trends, it directly answers which shipments need attention right now. And operations teams can use this to prioritize the shipments, they can take the preventive actions, and they can also reduce the delays proactively. So product importance index here is 0 for the low, 1 is for the medium, and 2 is for the high. And here in the weather severity index, you can see that 0 is for the clear weather, 1 is for the moderate weather disruption, 2 is for the severe weather disruption, and these are the discount offered waiting grams columns. The prediction 1 is equal to 1 is for the shipments to be delayed, and again you can see that these are the warehouse locations 0 to 4. And for the mode of shipment index, you can see that the 0 is for the ship, 1 is for the flight, and 2 is for the road. So now this is all about the high risk shipment table. And now let's see the weather impact on shipment delay risk in percent. So this visual shows the impact of weather conditions on shipment delays. I've already told you what is 0 for and 1 is for, 2 is for. Like 0 is for clear weather and 1 is for moderate weather disruption, and 2 is for severe weather disruption. So 0 is showing 35.95% shipment delay risk, and 1 is showing 34.46%, and 2 is showing 34.34%. So this is actually indicating that even though the weather feature is simulated, it is demonstrating how external factors can influence the operations. But in real world system, this can be replaced with live weather data to improve the prediction accuracy. And this visual highlights the external risk awareness in supply chain planning. So this is about this visual, and let's see the shipment mode analysis visual. It breaks down the delay risk by shipment mode, that is 0 is for ship, 1 is for flight, and 2 is for road. So here I found that ship mode has the highest delay probability, around 35.4%, and this insight helps in understanding which logistics method is contributing the most to delays. And from a business perspective, this can lead to route optimization and mode selection strategies also. So this is about it, shipment mode delay risk percent. And last visual, which is warehouse performance visual, which is nothing but showing the warehouse delay risk analysis in percent. So it shows that warehouse block 0 has the highest delay risk at around 40.08%, and this is very actionable insight because it indicates that there might be operational inefficiencies at that warehouse, and this allows team to investigate processes. They can improve the performance also and allocate the resources better at this warehouse location. So these are the warehouse locations, warehouse block numbers 0, 1, 2, 3, 4, and together all these 5 visuals transform the raw predictions into the actionable business insights, making this whole dashboard a true supply chain risk control tower. So again, now after this dashboard, I created a job pipeline to simulate the real production environment. I'll show you that job pipeline run, where you can see that all notebooks running in a sequence, and this automates the entire process from the data ingestion to prediction generation. And most important thing I want to tell you, so note that this, since the weather feature is simulated using the randomness, results may slightly change if the pipeline is rerun, but for consistency I'm presenting a stable run here. And most important part of the project let me tell you that I used a grant select query, which you can see here, that is grant supply chain gold access. um, Here it is. So this ensures that the dashboard and other users can access the data in a controlled and secure way, and overall this system provides real business value. So because system that this AI powered supply chain risk intelligence system helps in identifying the high risk shipments in advance, it helps in prioritizing the operations, it also helps in improve the decision making. So instead of reacting to delays, teams can act proactively, and this is what makes it a true AI powered supply chain risk control tower, and it demonstrates how data engineering, machine learning and analytics can come together to solve real world problems. And most important line I want to say in the end for this project is that this project is not just about building a model, it's about building a system that can actually support the real business decision. And I would want to genuinely thank Indian Data Club, Databricks and Code Basics for organizing this advanced Databricks AI challenge for and making me learning the advanced concepts of Databricks so that I could build this supply chain and operations domain project and AI powered intelligence system. So thank you so much, and thank you everyone for watching this video.